Okay, here we go. We're solving systems of linear equations. We're going to be doing it by graphing. A little bit later on, we're going to do it algebraically in a number of ways. But graphing is really your friend. You may want to just kind of salt that away in the back of your brain. Um, that's about as much as I'm going to say on that because I know we're going to do a bunch of it algebraically. But here we're going to look at two systems. And when we get to the point of actually graphing it, we're going to do it on our calculators, TI-84. But let's look at this first system. X minus y equals 2, along with 3y plus 2x equals 9. Now, in order to graph these on a graphing calculator, I want to get these equations in slope-intercept form. In other words, y equal. So I'm going to need to solve both of these equations for y. Now, this first one actually is in standard form. The second one's close to standard form. It would be if it was 2x plus 3y equal 9. But I need this in y-intercept form. So I'm going to work on this first one, x minus y equals 2. All right, well, I want to subtract x from both sides. So now I got negative y equals negative x plus 2. And I'm going to divide both sides of this equation by negative 1 because I need a positive y by itself. And when I do, let's see, negative x divided by negative 1 is just going to give me a positive x, and 2 divided by negative 1 is going to become negative 2. So there's my one equation that I'm going to end up graphing in a few moments. I'm actually going to look at the second system before we start graphing. And now I'm going to work on this second equation, 3y plus 2x equals 9. I'm going to subtract 2x from both sides. And once I do, I've got 3y equals 2x plus 9. And to get y by itself, I need to divide everything by 3. And so that's going to give me then negative 2/3 x plus 9 divided by 3 is 3. And so there's my two equations. Now, before I even graph it, I don't have the same slope. They're not the same equation or equivalent equation. So they're not inconsistent. They're not parallel lines, which they would be if they had the same slope. They're not the same equations, which means that they would be consistent and dependent with infinitely many solutions. And so it's only going to have one solution. It's going to intersect at one point, and when we get to the graphing calculator, we'll see what that is. But before we do, let's go ahead and work on the second system. Hold on. All right, so here we got y equals negative 2x minus 3, and 6x plus 3y equals negative 9. Well, I don't have to do anything to this first equation. It's already in slope-intercept form. But let's work on this second equation first, or next, I should say. So I'm going to subtract 6x from both sides. So I got 3y now equals negative 6x minus 9. And we're going to divide by 3 everything to isolate the y. And so negative 6 divided by 3 is negative 2x. And negative 9 divided by 3 is negative 3. And shazam, look what we got. These two equations are equivalent. And that means that they have infinitely many solutions. All right, so we're going to move over here to the calculator, and we're going to graph. We may just graph both sets of them and take a look at them. All right, well, you may recall that in our first system, I had simplified that to two equations, y equals x minus 2, and y equals negative 2/3 x plus 3. And it looks like I've got my window settings in kind of the default position. I think that's where I want to be. So I'm going in here to y equals, and so I'm going to not hit the comma button. Let's see, we're going to go, what was it, x minus 2. And then the second equation was negative, make sure I hit the negative button, not the subtraction, 2/3 x plus 3. All right, let's go look at the graph of this thing. So the first equation is coming in blue, second equation is coming in red, and I'm looking at this point of intersection right here, where x is at 1, 2, 3, and y is at 1, and that is my solution. We'd already determined we're going to only have one solution. And while we're here, let's go look at the table. Let's see what we got. So when x is 3, y1, the first equation, is 1, and y2 is also 1, and we can hereby tell from the table that this is our solution, our point of intersection. The dependent variable y in both equations is the same for the same value of x. This is another way of being able to tell exactly what my solution is, apart from looking at the graph where I'm looking for that point of intersection. Now, just for fun, let's go graph that second set that we already had said is going to be infinitely many solutions. And what we should see on this graph is that they're going to be the same line. The lines are just going to lie over top of each other. So let's see, when y equals negative 2x minus 3, and I'm going to graph that second one a little bit before, well, can't really do it. Who cares? Negative 2x, I better clear. Negative 2x minus 3. And we should see a blue line form and then a red line lay right on top of it. And there we go, infinitely many solutions. The calculator is going to be your friend if you know how to use it.